All right. Welcome to number 5 on the More Lens practice. We're going to take a quick look at what we do when we have a diverging lens or a diverging mirror. And the first thing we're going to look at is the math. So we'll notice that when you have a lens that's diverging, that parallel light, instead of getting turned through a focal length, you'll notice that this parallel light gets turned away. So there's something intrinsically different with the lens. And for that reason, when we go to do the math, for the focal, we're going to put in a negative number. So the focal length here will be negative, meaning that it's as if it was focused back here when it got diverged from parallel. Notice that all light's diverging when it comes off of a source. And so if it's already diverging and it hits a diverging lens or mirror, that just means it diverges even more. So there's no chance this light is ever going to converge. And that means that we're never going to have a real image. We're never going to have a projectable image. It's always going to be virtual. We're always going to have to use reverse ray tracing. So let's take a look at the math here. So F is negative 10 units. SO is 20 units. We get to use all the same equations. That's not a problem. So we go ahead and 1 over F, 1 over SI plus 1 over SO. And we plug in what we know, and we solve for SI. And what I'd like to do is just show real quick on the calculator how we would do that. So what I'll do here is just hit a parenthesis. And then I've got negative 10 raised to the negative 1 plus negative 20 to the negative 1. So this is basically negative 1/10. And then I've taken the 1/20th and brought it over to this side, which made it negative. But it's also in the denominator, which is why I'm putting that negative 1 on the top. And the parentheses. So at this point, I have 1 over SI. I'd like SI, so I'm going to raise this to the negative power one more time. Realize these parentheses here. Then this negative 1 means that we flip this over after the initial addition. So we get negative 6.67 units, centimeters, whatever it is. Now it's easy for us to go ahead and get the magnification because we can say negative SI over SO. The negatives cancel. We get a positive number, which means we're going to have an upright image. And we get a number smaller than 1, which should always be the case, which means to say that our image is smaller, as you can see, than the object. Okay, so that's how we do the math. Let's take a look when we do the lens drawing and the mirror drawing. When you have a parallel beam come, when it gets refracted away, it looks as if it was coming from the focal. The one going through the middle is easy. It just goes right on through. The one that's aiming at the far focal, that's this one right here, this one in the middle, is aimed at this far focal point over here. It gets diverged to parallel. So these 3 rays define where the image is if we reverse ray trace. So this one looks as if it was coming from back here. This one looks as if it was coming from back here. And similarly, this one looks as if it was coming back here. And that will focus a virtual image because the light doesn't actually converge, but it's as if it had been converged back here where the image is. Okay? Notice it doesn't matter where the object is, inside the focal, outside the focal, 2F, and none of that matters. If this object is anywhere over here, when it approaches this diverging lens, it's still going to be diverged, and we have a virtual image no matter where we put the object here, in both the lens and the mirror case. So looking at this one, if we have parallel light coming here and it reflects off the mirror, it's as if it was coming from this focal over here. Okay, quite simple. This one that's aiming at the far focal turns and goes parallel. And then finally, this one is the one that bounces off the mirror at equal angles. And then if you take this one here, this one here, and this one here, and reverse ray trace them, this one would be reverse ray trace there, and this one would be reverse ray trace there, you'll find your virtual image over here in the mirror case very similar to what we did with the diverging. So this is what we do when f is negative. It has to do with having a diverging lens or a diverging mirror. This, by the way, is called a concave lens, where this is called a convex mirror. But what's important is that they're diverging, which is why they both have a focal length that is negative. All right, thanks a lot, and that was number 5.